In this section, you're going to learn how to build RESTful services using ASP.NET Web API. I will also talk about data transfer objects or DTOs. You will learn what they are, why we need them, and how to use them. Now, let's get started. Okay, let's have a quick review of ASP.NET MVC architecture. So when a request arrives at our application, MVC framework hands off that request to an action in a controller. This action most of the time returns a view, which is then parsed by Razor View Engine, and then eventually HTML markup is returned to the client. So in this approach, HTML markup is generated on the server and then returned to the client. There is an alternative way to generate HTML markup. We can generate it on the client. So instead of our actions returning markup, they can return raw data. Now you might ask, what is the benefit of this approach? Well, there are a number of benefits. One is that returning raw data to the client requires less of server resources. By delegating the task of generating HTML markup to the client, we can free up server resources and potentially improve the scalability of our application, because each client will be responsible for generating their own views. The second benefit is that raw data often requires less bandwidth than HTML markup, so the data potentially arrives faster at the client, and this can improve the perceived performance of the application. Now, just to clarify, we're not talking about significant performance improvements here, but overall, the application may appear to be a bit more responsive. The third benefit of this approach is that we can build a broad range of clients, like mobile and tablet apps. These apps simply call our endpoints, get the data, and generate the view locally. We call these endpoints data services or web APIs because they just return data, not markup. Now, these web APIs are not just for building mobile and tablet apps. Other websites can consume our web APIs and build new functionality. For example, many popular websites like YouTube, Facebook, and Twitter expose public data services which we can consume in our web applications. We can merge their data with the data in our application and provide new experiences to the user. So these are the benefits. And by the way, these data services are not only for getting data. We can have services for modifying data, like adding a customer. Now, the framework we use to build these data services is called ASP.NET Web API. This framework was developed after ASP.NET MVC, but it follows the same architectural principles. So it has routing, controllers, actions, action result, and so on. There are a few minor differences that you will learn about in this section. In the next version of ASP.NET MVC, called ASP.NET Core 1.0, Microsoft has merged these two frameworks into a single unified framework. But ASP.NET Core is not ready yet, and it's going to take a few more months until it's finally released. So with ASP.NET Web API, we can build web APIs or data services that can be consumed by a broad range of clients. Now, as far as this course is concerned, we're not going to build a mobile app around our web APIs because that's really beyond the scope of this course. But I'm going to show you some really useful applications of web APIs. For example, instead of generating the HTML markup for the list of customers, we can expose a web API to return the list of customers, and then we use a jQuery plugin called Data Table to generate this table on the client. This plugin gives us pagination, searching, and sorting out of the box. We don't have to write any additional code for that. Okay, so you know what HTTP services or web APIs are. Now, over the next few lectures, we're going to build a web API for implementing CRUD operations around customers. Our API endpoint will be at /API/customers. And here we're going to support a few different kinds of requests. To get the list of customers, we should send an HTTP GET request to this address. To get a single customer, we'll send an HTTP GET request and add the ID of the customer in the URL. To add a customer, we send an HTTP POST request to this endpoint and add the customer data in the request body. Now, in case you're confused about HTTP GET and HTTP POST, these are basically different request types. We use GET to get a resource and POST to create one. Now, to update a customer, we'll send an HTTP PUT request to this URL. So the ID of the customer is in the URL, and the actual data or properties to update will be in the request body. And finally, to delete a customer, we'll send an HTTP delete request to this endpoint. So what you see here, in terms of request types and endpoints, is a standard convention referred to as RESTful Convention. REST stands for Representational State Transfer, and I know it probably doesn't make any sense to you, because it was originally part of the thesis of a PhD student. So let's put the theory aside and just focus on the practicality. This convention you see here is what you find in most HTTP services or web APIs out there. So we're going to follow the same convention to build a web API for CRUD operations around customers. All right, now in Solution Explorer, right-click Controllers and add a new folder. API. Now right-click this folder, add controller. Now from the template, this time we're going to use Web API 2 controller. Let's call this customers controller. Note the plural naming convention here. Okay, the first time you add an API controller, you get this README text file that guides you how to configure Web API. And it's pretty easy. In Solution Explorer, scroll down, open up global.asax.cs. So this is application start method. Now back to the README text file. Here it says add the following line to the beginning of application start method. So simply copy this and paste it here. Now you need to import the namespace, which is system.web.http. We're done with this file. Save. Let's close it. So here's our API controller. The first thing I want you to note here is that this class derives from API controller as opposed to controller. Now let's add an action here. Public. We want to return a list of customers. So we can set the return type to IEnumerable of customer. Import the namespace, which is vidly.models. Now let's call this get customers. Now because we are returning a list of objects, this action by convention will respond to get/API/customers. So this is the convention built into ASP.NET Web API. Now in this action, we're going to use our context to get the customers from the database. So first we create a private field, application DB context, underline context, initialize it in the constructor. So nothing new so far. And here return context.customers.toList. Now another action to get a single customer. So that would respond to a request like this. Public customer, get customer, integer ID. Let's get the customer. Context.customers.single or default. C goes to c.id equals ID. Now, if the customer is null, we throw a new HTTP response exception. This method takes an enumeration that specifies the kind of error. So we're going to use HTTP status code .not found. So this is part of the RESTful convention. If the given resource is not found, we return the standard not found HTTP response. Otherwise, we return the customer. Now, another action. I want to create a customer. I want this to respond to a request like this. So we post a customer to customers collection. Public. What should we return here? By convention, when we create a resource, we return the newly created resource to the client, because that resource will probably have an ID generated by the server. So customer, create customer, customer. So this customer object will be in the request body, and ASP.NET Web API Framework will automatically initialize this. Now we should mark this action with HTTP post, because here we're creating a resource. So by applying this attribute here, this action will only be called if we send an HTTP post request. Now, alternatively, we could name the action using a convention, call it post customer, and this way we don't have to apply this attribute here. And this is the approach that tutorials on Microsoft website teach you. But I personally find this a poor approach, because if you rename this action in the future as part of code refactoring to, let's say, create customer, your code is going to break. This action will no longer respond to HTTP post requests. In fact, to be honest with you, I have broken an API like this before. So don't use this approach and prefer to explicitly apply this HTTP post attribute here. Now here, first we validate this object. So if model state not valid, we throw new HTTP response exception. And by convention, the exception would be of type HTTP status code.bad request. Otherwise, we add this object to our context and save the changes. Context.customers.add customer. Save changes. Now at this point, the ID property will be set based on the ID generated from the database. Now we return this customer object. Another action. I want this one to respond to a request like this. So public. Now in terms of return type, we can either return a customer or void. Different people have different opinions here, but in my opinion, either works. So void, update customer. Now here we need two parameters. One is ID, which is read from the URL, and the other is customer, which comes from the request body, similar to this action here. Again, we need to validate this input, so I'm going to borrow some code from the other action. Now at this point, we get the customer in database, single or default. C goes to c.id equals ID. Now it's possible that the client sends an invalid ID, so we need to check for the existence of this object. If customer in DB is null, we throw another HTTP response exception with status code not found, just like before. Now, otherwise everything is good, so we need to update the customer. Customer in DB, that name, duplicate this line, birth date is subscribed, and membership type ID set here. Now, potentially in the future, we can use a tool like AutoMapper. So if we have 10 properties in our customer object, we can have this tool to automatically map them for us. We don't have to explicitly set each property here. Now, finally, we save the changes and we are done with this action. Now, one more thing. We need to apply HTTP put attribute here. And the last action. We want this action to respond to a request like this. So public void delete customer. We pass the ID here. Now I'm going to borrow some code from the other action. We need to get this customer from database first and check if it exists or not. Paste it here. Now at this point, context.customers.remove this customer in DB. So this object will be marked as removed in memory. And then we call save changes and we're done. Just remember to add HTTP delete attribute here. So this is how you build APIs with ASP.NET Web API. Next, I'm going to show you how to test this API. All right, now back in our browser, if we change this address to /API/customers, we can see the list of our customers returned as XML. So ASP.NET Web API has what we call a media formatter. So what we return from an action, in this case, the list of customers, will be formatted based on what the client asks. Let me show you what I mean. So back in the browser, open up Chrome Developer Tools. In the Network tab, refresh. Okay, here's our request. Under response headers, look at content type. If we don't set the content type header in our request, by default, the server assumes it's application/XML. So here are the response headers, and here you can see the request headers. As you see in the request headers, we don't have content type. Now let me show you a better way to test this API and get the data as JSON. So in Google, search for Postman REST Client. Look at the second link, Postman REST Client Shortcut. You can see this extension is added to my Chrome. In your case, you're going to see an install button. So once you add this to your Chrome, then you're going to see this icon on the toolbar. Let's click this. So this is Postman extension. I'm going to click this button so we have more space. Okay, here we put the URL of our API endpoint. So I'm going to go to the other tab, copy this address, and then paste it here. Send. Now we can see the list of customers as either JSON or XML. Now most of the time, we'll be using JSON because that's native for our JavaScript code. XML is often used in large organizations, especially government organizations, which are always behind the modern technology. JSON format is more lightweight because we don't have the noisy opening and closing tags like XML. Now let's create a customer. First, I'm going to select one of these customers. Copy. Now change the request type to post. Now here we can add properties of the customer as key value pairs, or we can go to the raw tab, set this to JSON, and paste a JSON object here. Now we remove ID because that's going to be generated by the server. And change the name of this customer to Joe Smith. Now click send, scroll down. We got an exception from the server. The request entity's media type text/plain is not supported for this resource. So because in this request we have not set the content type, by default it assumes it's plain text. So scroll up, click headers, and add content-type and set it to application/JSON. Now send again. Beautiful. So the status of this request is 200, which is the standard code for an OK response. And here's the body of the response. So we got a complete representation of the customer we just created. And you can see the ID is set to 7. Now you can follow the same steps and test other endpoints, updating a customer, deleting a customer, and so on. So as a good practice, whenever you build an API, before you write any JavaScript code to consume that API, first test it here using Postman and make sure it's working. Okay, next I'm going to talk about a couple of issues we have with the design of our API. Okay, so we've built this API, but there are a couple of issues with this design. Our API receives or returns customer objects. What's wrong with this? Well, this customer object is part of the domain model of our application. It's considered implementation detail, which can change frequently as we implement new features in our application. And these changes can potentially break existing clients that are dependent on the customer object. For example, if we rename or remove a property, this can impact the clients that are dependent on that property. So basically, we need to make the contract of this API as stable as possible. Of course, I'm not saying this contract should never change, but because it's a public contract, it should change at a reasonably slower pace than our domain objects. Now, to solve this issue, we need a different model, which we call a data transfer object, or DTO. This DTO is a plain data structure and is used to transfer data from the client to the server or vice versa. That's why we call it data transfer object. By creating DTOs, we reduce the chances of our API breaking as we refactor our domain model. And of course, we should remember that changing these DTOs can be costly. So when we need to change them, we should plan a proper strategy. Now, this goes in the space of API versioning, which is beyond the scope of this section. What I want you to take away from this lecture is that your APIs should never receive or return domain objects. That's one thing. Another issue is that by using a domain object here, we're opening up security holes in our application. A hacker can easily pass additional data in the JSON and they will be mapped to our domain object. What if one of these properties should not be updated? A hacker can easily bypass this. But if we use a data transfer object, we can simply exclude the properties that can be updated. Now, in Solution Explorer, add a new folder, DTOs. And here we add a new class, customer DTO. Now for the starter, I'm going to go in the customer class and copy all these properties and then paste them here. Import the namespaces, which is system.componentModel.data annotations. Now, we should exclude membership type because this is a domain class and this property here is creating dependency from our DTO to our domain model. So if we change this membership type, this can impact our DTO. So here we either use primitive types like integer, string, byte, whatever, or custom DTOs. So if you want to return hierarchical data structures, you would create another type called membership type DTO. This way your DTOs are completely decoupled from your domain objects. So delete. Also, we don't need any of these display attributes because earlier we used them to render labels in our forms. Delete. Delete. That's it. Now back in our controller. So anywhere we return a customer object, we need to map it to a DTO first. And also in the methods where we modify a customer, like create customer or update customer, we need to map this customer DTO properties back to our customer object. Now doing all this mapping by hand can be tedious. So next I will show you how to use AutoMapper to easily map these objects. Okay, so open up Package Manager console. Remember the shortcut we created before? Alt/period. Now install -package AutoMapper. Add the version number here so you get the exact same experience as me. So in case in the future AutoMapper has a newer version and it's different, you don't run into issues. So the version I'm using is 4.1. Okay, beautiful. Now we need to create a mapping profile which determines how objects of different types can be mapped to each other. So in Solution Explorer, in app_start, add a new class. Call it mapping profile. We derive this class from profile, which is defined in AutoMapper namespace. Here we add a constructor and use mapper.createMap method to create a mapping configuration between two types. Now this is a generic method that takes two parameters, source and target. So I want to be able to map a customer to a customer DTO. I'm going to duplicate this. I also want to be able to map a customer DTO to a customer. When we call this createMap method, AutoMapper uses reflection to scan these types. It finds their properties and maps them based on their name. So this is why we call AutoMapper a convention-based mapping tool, because it uses property names as the convention to map objects. So here's our mapping profile. Now we need to load this when the application started. So in Solution Explorer, open up global.asx.c#. Here we use the mapper class defined in AutoMapper. Dot initialize. Here we need to pass an action. Now, whenever you see an action, you can pass a lambda expression. If this doesn't make sense to you, check out my C# Advanced course on Udemy. Now here we pass C as in configuration, goes to c.addProfile. This is a generic method. And here we specify the type of our mapping profile. Mapping profile, which is defined in this namespace. Okay, so this was the setup code. Now back in the controller, in getCustomers method, first I'm going to change the return type to IEnumerable of customer DTO, defined in vidly.dto's namespace. Now we need to map these customer objects to customer DTO. So we use link extension method select. Here we need to pass a delegate that does the mapping. We can use mapper, the same mapper class defined in AutoMapper namespace. .map, generic method. We specify the source and target types. So we want to map customer objects to customer DTO. Now I'm going to remove this parenthesis because we are not going to call this method. If we call it, it gets executed. But here we need to delegate a reference to this method. Delete. That's it. Now let me show you another example. In getCustomer method, we're returning one customer object. So we cannot use the select extension method of link. Instead, we use mapper.map. Again, customer to customer DTO. And then pass this customer object as an argument to this method. Now we have this red underline because we need to change the return type of this method to customer DTO. Now let's take a look at another example. Create customer. So we should change this to customer DTO and also return customer DTO. Now here we need to map this DTO back to our domain object. So actually I would rather to change this. I'm renaming it to customer DTO. And then here I create a new customer object using mapper.map customer DTO to customer. And then pass this DTO here. Now, once we have the customer object, we add it to our context, call save changes. Now this customer object has an ID that is generated by the database. So we want to add this ID in our DTO and return it to the client. So customer DTO.ID equals customer.ID. And the last example, which is a little bit different. Update customer. First, we change the input to customer DTO and also rename this parameter. Now here, I'm going to use mapper.map. We want to map a customer DTO to a customer. But this time I'm going to pass two arguments to this method. The source object, which is our customer DTO, and the target object, which is customer in DB. In previous examples, I didn't pass a second argument to this method. So it created a new object and returned it, which we got here. But if you have an existing object, you can pass that here as a second argument. Now here, the reason I'm doing this is because this object is loaded into our context. Look, you're reading it here. So I want our DB context to be able to track changes in this object. Now we no longer need these few lines anymore. Also, we can see the generic parameters are grayed out because the compiler can infer from the objects we have passed to this method what are the source and target types. So we can get rid of that. So this is how we map objects using AutoMapper. Now, AutoMapper has a few features that you might find useful in certain situations. For example, if your property names don't match, you can override the default convention. Or you can exclude some of these properties from mapping. Or you may want to create custom mapping classes. To learn more about these features, you need to look at AutoMapper documentation because that's really beyond the scope of this course. Next, I'm going to talk about Camel notation. All right, now look at the result of calling our API to get the list of customers. The properties of these JSON objects are named using Pascal notation. So the first letter of every word is uppercase. But in JavaScript, we use Camel notation. So the first letter of the first word should be lowercase, and the first letter of every word after should be uppercase. So with the current situation, if we consume these objects in JavaScript, our code is going to get a little bit ugly. So let me show you how to configure Web API to return JSON objects using Camel notation. In Solution Explorer, in app_start, open up Web API config. So you can see that Web API framework, similar to MVC framework, has a configuration class, and inside this class, we have our default routing rule. You can see in this route template, we don't have the action, as we did with ASP.NET MVC routes. Now let's move on. So here, we're going to use this config object, and then go to formatters dot JSON formatter dot serializer settings. Let's store a reference to this object. Now, to enable camel casing, we need to set a couple of properties. Settings dot contract resolver equals new camel case property names contract resolver. And the second one is settings dot formatting. We set it to formatting dot indented. Now let's build. Back to the browser. Send again. All right, here is our camel notation. You can see that the first letter of every word is lowercase. Next, I'm going to talk about action results in Web APIs. All right, look at this create customer action. Here we're simply returning a customer DTO, which would eventually result in a response like this. So the status code of this response will be 200 or OK, and in the body we'll have the customer object serialized as JSON. But in RESTful Convention, when we create a resource, the status code should be 201 or created. So we need more control over the response returned from our action. And to make this happen, instead of returning customer DTO, we're going to return IHttpActionResult. This interface is similar to ActionResult we have in MVC framework. So it's implemented by a few different classes. And here in API controller, we have a bunch of helper methods to create an instance of one of the classes that implement this interface. Now here, if the model is not valid, instead of throwing an exception, we use the helper method bad request. So this bad request method returns a bad request result, which is a class that implements IHttpActionResult. Now at the end, instead of returning customer DTO, we call the created method. Here, as part of RESTful Convention, we need to return the URI of the newly created resource to the client. URI stands for Unified Resource Identifier. So if the ID of our new customer is 10, the URI to this resource would be something like this. So we create a new URI. This class is defined in the system namespace, so be sure to import it on the top. Now in the constructor, we need to get the URI of our current request, which would be something like this, and then append a slash and the ID of the newly created customer. To get the URI for the request, we use the request property of the controller and then request URI. Now append a slash and the ID of this customer. Now, as the second argument to the created method, we need to pass the actual object that was created, which would be customer DTO. Now, before testing this, let's go back to customer DTO. We need to temporarily comment out this attribute. Otherwise, we're going to get an exception. Let me explain why. So let's take a look at its implementation. Look here. We're casting this object instance to customer. But if this attribute is applied on one of the properties of customer DTO, we're going to get an exception here. Now, ideally, we should have only one way to create a customer. Currently, we have two different endpoints. One is an API endpoint we just created, and another one is the normal MVC action we created in the section about forms. So if you want to go with the API approach, we should drop that old MVC action and modify our form to post to our API endpoint. But that's beyond the scope of what we are doing now. So let's keep the application as is. We want to keep the customer form and instead go back to customer DTO and comment this out. Now build, back to the browser. In Postman history, I've got a request to post to our customers collection. So let's execute this again. All right, look. First of all, the status is changed from 200, which was okay, to 201, which is created. So this is confirming to RESTful Convention. Also, if you look at the headers tab, you see a new key here, location, and look at the address. So that's the URI of the newly created customer. Again, this is part of the RESTful Convention. So in web APIs, prefer to use IHttpActionResult as the return type of your actions. Now, let me show you one more example, and I will leave the rest as an exercise for you. Let's look at get customer action. So first we change the return type to IHttpActionResult. Now, if the customer is null, we return not found. Otherwise, we use OK helper method and put this DTO in this method. Pretty simple. All right, now as an exercise, I want you to build an API for CRUD operations around movies. So we want to have different endpoints for getting all movies, getting a single movie by ID, as well as endpoints for adding, updating, and deleting a movie. Now, as part of this exercise, you will most likely get an exception when updating a movie. The exception message is the property ID is part of the object's key information and cannot be modified. I've attached a PDF to this lecture and explained what this error means and how to resolve it. So go ahead and implement this API with all the best practices I showed you in this section. Once you're done, have a look at my solution on GitHub. Alright, in this section, you learned how to build RESTful APIs using ASP.NET Web API Framework. More specifically, you learned about Postman for testing APIs, Data Transfer Objects or DTOs, AutoMapper, Action Results, and Camel notation in Web APIs. In the next section, we're going to shift our focus to client-side development. I will show you how to consume the APIs we have built in this section using jQuery and implement a few nice features in our application. So I will see you in the next section.